Yeah, good morning. So what we really want to talk about in this next 20 minutes is the Kanister project, and also some of the thought provoked around, so the mention of Kahoo, how could that fit with what Kanister's doing? It sounds all like it's backup and restore. There's some elements that we'll get into, and it's about granularity around the data services. So firstly, I'm Michael Cade. I'm a field CTO, but I'm a technologist. The fancy title is great for LinkedIn, but I'm a technologist, right? I love playing with tech. I love sharing or breaking down the technical verbiage and turning it into layman's terms. I've been around data protection, the storage space for the last 20 years. I know I look young, but it's true. I'm an Open UK ambassador, so I'm a big fan, obviously, around the open source world and what that does and what that gives us from a community perspective. But equally around that, I'm a big proponent of open source learning. One of the projects that I started off the back of the pandemic was 90 Days of DevOps, free open source learning that we have a GitHub repo. There's 23,000 stars. I wish I'd have gone to an investor. We would have been a lot richer right now if that was the case. But you can find me over social media and other places as well that you'll see me popping up, talking all things, hopefully all things data and storage. So and specifically Kanister is a project around Kubernetes, but we'll get into that. But I think there's a debunk of a myth around stateless workloads, and I think I'm surrounded by peers and friends of stateful workloads within the cloud native ecosystem, is that this is happening, right? We've seen from a Kubernetes perspective over the last 5 years, we've seen data services, a focus around storage and statefulness within our Kubernetes cluster just continue to be there. We've had the CSI driver, and then that's exponentially grown in terms of what do we see out there in the field, both from an open source, but equally from an enterprise perspective as well. So Kubernetes is maturing, and so are the services, the data services that we see within Kubernetes. So here's a graph from a Datadog report from last year that clearly we can see data services, Redis, Elasticsearch, MySQL, Postgres, and I'm sure you've got your own examples of data services that you're seeing in the cloud native ecosystem. And I think that then leads us on to, okay, what does consistency, sorry, there's a couple of pictures there. That leads us on to the consistency story, because a database, in theory, a database is the same regardless of whether it's running on a virtual machine, a physical machine, a cloud-based service, a PaaS-based service, or in Kubernetes. If we just take a backup of the application, the container, or the operating system, that's like pulling the power cable out of our computer, if you will. If you plug it back in, will it come back up? Yes, it probably will. But if that's highly transactional, what are we losing from that perspective? So we're always going to advocate, like, let's shut down things cleanly, or at least let's pause some I/O so that we can get to the right state for our application. Remember, this is probably the mission critical data service within our cluster. So we have different levels of consistency. Crash consistent being I need a backup. There is no tool set that allows me to QoS that workload. So I have to get some sort of backup. So pulling that cable in that type theory. But then we move down that spectrum around application consistency. A lot of the tools that I mentioned around MySQL, Postgres, Elasticsearch with their dump application consistency allows us to at least get some sort of copy of our database so that when bad things happen, we can get them back. Then we've got things like logical backups, being able to leverage that and push that out into object storage or away from our production environment. And then system consistency around, I want to protect everything around that. What makes up that application? Now, when we get into the microservice world, there's a lot of different moving parts there. There'll be different artifacts within our Kubernetes cluster. But for consistency-wise, we have to think about capturing all. Now, from a Kanister point of view in particular, I'm going to focus on the two middle ones. The application consistent, where we can drive and orchestrate those native tool sets. But remember, again, we're in that microservice world, so we have the choice now to be able to choose the best data service for the job. We don't no longer have to just go, oh, we've paid for a Microsoft SQL license or an Oracle license, and we're going to throw as many databases in there as we possibly physically can before we have to move on to the next. In the microservice world, we can choose MySQL or Mongo or the particular type of database that suits our service. So whether that's a authentication model database in MySQL, a catalog using Postgres, maybe a stock database using something like a document DB type database. And then obviously you've got your messaging queues and other such types in there. So this then leads us on to a project that we have called Kanister. So Kanister is focused around capturing that application-specific data. So when we look at Postgres, we think of PG dump. When we look at MySQL, we think of MySQL dump, and so on and so forth between all of the other data services. What this allows us to do is bring that into one single control unit or application framework that allows us to trigger those in an orchestrated way. So if you do have multiple data services, instead of using a bash script or some other convoluted way of being able to trigger all of those MySQL dumps or those application consistent backups in order, we can do that from a Kanister point of view. So I really want to spend the next 5-10 minutes just talking about what Kanister is, how it works, how it's simple, and then get into a bit of a short demo, and then where to find out more. So from a Kanister point of view, there's well, let's rewind. When Kanister is deployed within your Kubernetes cluster. It then brings us 3 custom resource definitions, 3 CRDs. One is an action set, and this is what's really going to control and tell you, or tell the system, this is what I want you to do. So an action set could be for backup, it could be for restore, or it could be for delete. That's literally the functions that we have within Kanister. We then have the concept of a blueprint. Now, if you think about blueprints, it is a way in which we can tell the application what we want to protect. So if it's MySQL, we're going to trigger that MySQL dump command based on the application that we have running. Or if it's Elasticsearch, we're going to do that. And I'll show you an example of a blueprint. But this is one of the benefits of it being open source as a framework, is that we're seeing the community create those blueprints against some weird and wonderful data services that are out there. And we know how many databases we have access to as a community and within businesses as well. So we need those blueprints to be able to ensure we can protect those. Then we have the concept of a profile. Now, a profile is somewhere to store those dump files or those logical backups. So that could be S3, that could be an NFS location, basically some sort of disk somewhere that we're going to store that data. And if we think about so Kanister, as I said, is deployed within your Kubernetes cluster. So from a deployment point of view, it's a Helm chart deployment, and that then gives us our Kanister operator within our cluster. If you've got multiple Kubernetes clusters, then you deploy Kanister each time. Then we have our long list of community blueprints that we see here. Just on the GitHub page, if you go to kanister.io, you'll see all of the blueprints, and would love, obviously I'll get to that as well, as around from a contribution community perspective. And then we define that blueprint based on the database workload that you have within your environment. So then, okay, we get to the point where, okay, we need to make something happen. We've created a profile, some sort of, and I'll get to that as well, and we've got our blueprint for our particular application. So we create our action set. So an if this, then that type scenario. The action set is going to enable us to, it's going to trigger that blueprint against the application that we have. It's then going to go through the process of the blueprint to give us, or to hopefully complete that action and give us a good, solid copy of our data. So what that looks like in terms of a flow, we have our action set, we trigger that off, the controller, the operator, then goes and finds that blueprint, and I'll show you a little bit more in the demo. And then with that, it then talks to the database itself, so it might be whether it jumps into the actual database pod, depends on from a security perspective, or it uses some sort of sidecar integration. I'm not going to get too deep into the weeds, I don't have a lot of time to get into that security model, but because it's a CRD, we can be secure in that manner. So then we use this Kanister function. So depending on what that action set wants us to do, backup, restore, delete, it's then going to use that function within Kanister and say, this is what I want you to do. And I'll show you a blueprint later on as well. So then once we've done that, it's going to give us that tar file, that consistent copy of our application data, and it's going to send it out into whatever that storage base is, whether it's S3 or some sort of object storage, or whether it's NFS or some other disk-based repository. And then it's going to report back and say, we're all good or we're all bad, and it's going to give you that action set. It's going to complete that task, so whether it's complete or whether there's an error. So that's why we have an action set. It's the defined way of being able to not necessarily schedule, because there's no schedule or orchestration in here, and hopefully that's becoming clear, or it will become clear later on in the day how Kahoo can really help here as well. Okay, so from a demo point of view, I normally always use things like MySQL or Postgres because we generally see that out in the field, and that's what the majority of our users are using. But I thought we'd change what the data service actually looks like and use Elasticsearch. Elasticsearch, it still uses Elastic Dump, so it gives us the ability to dive in. From an architecture point of view, you'll see here that I have a very simple demo. I have a namespace with Elasticsearch, and I'll show you that on the demo, and I have my Kanister operator running in the Kanister namespace. I also have, and this is against all best practice, I have MinIO running on the same Kubernetes cluster. Please do not do that. We want to send backups out of the cluster. What happens if the cluster dies? That's when I need a backup. In this demo, it won't work. So yeah, bear with us on that. It's just that for a demo purpose. So then you see that we've got those 3 CRDs as well. Okay, so let's hopefully this, and everyone can see. So first of all, if I go and check what namespaces I have within my Kubernetes cluster, you're hopefully going to see an ES data and a Kanister, or no Kanister yet. We're going to deploy Kanister. So you see ES test is my Elasticsearch, right? Very simply put, that's where my application is, PVCs are, and I've also got that MinIO. Now let's imagine this MinIO cluster is outside of the Kubernetes cluster. But you can see there I had a bucket called Kanister bucket as well. So again, to deploy Kanister, we're going to use Helm repo, add that Kanister Helm chart, and then we're going to use the Helm install command to that. So you see that I already had Helm as part of that. So then we're going to use this command, Helm install Kanister operator, in the namespace of Kanister and create that namespace. And it takes seconds to come up. So here we go. So the Kanister operator is now up. So next up, we want to create a profile, somewhere to store our data. But first of all, you see our CRDs, our custom resource definitions, action sets, blueprints, profiles. So obviously I've gone through what they do. So I'm going to use a CLI, which is also part of Kanister, called CanCTL, and that's what I'm going to use to create that profile. So basically what I'm doing there is I'm using that to create that profile in that CRD to hit that MinIO bucket that I had created. So you'll see here that if I do kubectl get profiles, I've got my S3 bucket. We can have multiples depending on where you want to send those backups. Not very clear, but this is where if you go to kanister.io and go over to the GitHub, you'll see a much clearer, concise example of what the profile looks like, but equally what the blueprints look like. And the blueprints are built up of the backup action, what does that need to look like, and then also the restore, and then the delete for retention. So we've got our blueprint now deployed as well, with inside the Kanister namespace, because we might have multiple copies of that data service that you leverage that same blueprint. So I'm going to jump into my Elasticsearch. I obviously need to show you some data, because it wouldn't be a data protection demo if I didn't cause some havoc and break things. So here you can see that we have some customer details here that will show us John Smith at the top. That's probably the easiest thing to remember here. And you can see that we have a document count of 1, all good stuff. We've got some data. So then we're going to come out of that, and then we're going to create our first Kanister backup. And that's going to offload into our MinIO S3 repository, and then we're going to cause some proper havoc and hopefully restore it. the spoiler is this is a demo video, so I know that it works. So let's protect the application. So again, we need that profile. We're now going to create that action set. So we need the profile name to create that action set. So you'll see that I'm just using that. I'm creating an environment variable of Kanister profile based on what I've just found. Now I'm going to use that CanCTL to create that action set. You can see here that action is the backup. The namespace is focused on Kanister, and we're going to use this particular blueprint. We're going to define some variables in there. And then that runs pretty quick, as you can imagine. My Elasticsearch is not very big. There's not a lot of data in there. But if we jump into our bucket now, you'll see that we have that tar file. And in theory, that's now a backup of our mission critical data that is in that Elasticsearch instance. Okay, so now I'm going to jump back into Elasticsearch and just show, well, cause a problem, and then we're going to restore. And I think the emphasis on, so while I'm doing this, while I'm causing problems, the emphasis on, okay, Elasticsearch is one thing. You could easily write a cron job or a bash script or both that allows us to create that natively. Like, let's just run our own sidecar that allows us to run Elasticsearch dump or Elastic dump. But imagine now you've got hundreds of MySQL instances, you've got hundreds of Postgres, and they've got different reasons and different deployment types. Kanister enables us to take all of those and simplify that action. No one wants to be spending too much time around data management. Again, I'm probably surrounded by people that actually will do that. But there's a need within the community for a simplifying way of being able to protect those applications. So hopefully you saw me cause some problems. I basically deleted the contents of the database, or maybe even deleted it. So you can see here that we have our action set that we just ran. So that was a backup, and you can see that the progress was complete. So I want to take that backup action because that's what I want to use as my source from a restore point of view. So I'm going to create another action set based on that, and I'm going to say, right, where do you want to? And now the action though is a restore versus a backup. So you can see that we've created our action set based on those configurations. If we go back to look at those action sets, you're going to see 2 in there, and because there's not a lot of data, obviously that happens really quite quick. One's a backup that we just created with our good data, and one's a restore to get us back to that location. So now, if we jump back into Elasticsearch, the spoiler is I'm pretty sure that the data is going to be back. But again, going back to that point is Kanister enables us just to have one point of contact, one framework, one API that enables us to go in and create these action sets against multiple different data services. And the amount of community people that I've spoken to, it's not just as simple as Elasticsearch, Postgres, MySQL, Redis, etc. People are running this against their own custom data services as well to create those protections. Again, this is me proving that the data is now back, and I think we're good on the demo. So then that leads me on to Kahoo. So that was mentioned before, and you're going to hear more about that during the day. So Kahoo being a data protection platform, orchestration engine, very much obviously open source from that perspective, and it gives you that ability to orchestrate the backup, the restore, and perform disaster recovery against your workloads within Kubernetes. So it sounds quite similar to what we're doing from a Kanister point of view, but Kanister is very much focused on just the data service. There is no orchestration, there is no scheduling within Kanister. Kanister is focused on purely the data service. So when you think about your application that you've deployed to Kubernetes, it's not just a database pod, it's not just a PVC, it's not just the stateful workload. It's everything along that as well. It's going to be built up of secrets. It's going to be built up of other artifacts within Kanister. And that's where Kahoo potentially comes in. Like that, if you could drive Kahoo to create an application level, a system-wide application consistent backup, that becomes a little bit more useful to our communities as well to be able to protect that. So just simply put, Kahoo gives us that snapshot and backup of your Kubernetes resources. It gives us the scheduling and orchestration. From a Kanister perspective, it gives us that application level management as well as that blueprint mechanism, which basically it can be extremely customized. The other thing that Kanister can do is go outside of the Kubernetes cluster and start protecting data services within virtual machines. Not everyone has gone, I'm going to put my Microsoft SQL server into containers yet. So there's still an element where that application still lives outside of the cluster. So this opens up the door to, or potentially to PaaS-based services such as AWS RDS or Google Cloud SQL. Kanister, we have blueprints in the examples that allow us to go out, but obviously it's still our application using that data service, so we want to protect everything, not just that. Okay, so a QR code for those interested. There's a couple of things to mention here. That QR code will take you to kanister.io. It's kind of like the front-end portal, but that will then get you to the GitHub repo, which is where you'll find all the examples and documentation as well. We have, from a community perspective, we have bi-weekly calls where we'll go through some of the new stuff. We actually have a hands-on lab that means you don't have to go and deploy your own Kubernetes cluster. So you can jump into kubecampus.io and it will use Instruct as a base layer that gives you access, and you can get hands-on with Kanister and the example blueprints. Now our plan over the next 12 to 18 months and forevermore is how do we build this up to be more blueprint functionality. So the important part there is Kanister itself is an open source project. So there's obviously a community of contributions welcome there, but equally the blueprints is a good potential first look into operationalizing the creation of blueprints, because it's generally the operators that, the operation team that know what that data service looks like. How do you get started? I'm not going to go through all of those, but basically get yourself on GitHub, go and find out more there. Now, I've been told that I have to put this next in because it's not by Soda, but so I work for Veeam Software. We're obviously focused for the last 16 years around data protection, and the community is a big part of us. Not open source, but we have community editions, free editions for us that technologists that like to play around with tech at home. So Kasten K10 is that orchestrated, that enterprise solution that enables us to protect those Kubernetes workloads, including leveraging that Kanister functionality. So I think with that, thank you very much. And I'll be around all day, so come and have a chat. I'll be more than happy to help. Thank you.
Very, very good. Last but not least, Michael, before you leave, can you just let folks know about your other initiative, 90 Days of DevOps?
Yeah, so I mentioned that at the start. So 90daysofdevops.com was really, I'm very much for the infrastructure and operations side, right? 2-3 years ago, I was given this parachute role to come into Kasten. Kasten was an acquisition for Veeam. I've been at Veeam for 8 years. And I'd done bits around things like infrastructure as code. I'd done bits around configuration management, a lot about Linux. But there's a lot of asset or a lot of facets to DevOps that, well, and there's a lot of differences between different companies, what DevOps means and what a DevOps engineer role is. So I felt like I had a huge gap. I've always been massively keen on helping and giving back to the community. So I created 90 Days of DevOps, and it is what it sounds like. I went through 90 days from January the 1st to March the 31st. 90 days, first quarter of the year, and every day I blogged something about elements of DevOps. You'll see that it's broken down into different chunks, so learning a programming language, but from a DevOps point of view, not necessarily a software developer. Learning Linux, learning networking, learning infrastructure as code, and it's grown to be 23,000 stars. That was 2022. 2023, I decided that 110,000 words in total for no one needed to hear from me again. So 2023, I asked some friends within the community to bring their subject matter expert type topics, and that's what we did. The big thing around what we're going to do next, because it's still growing, which is crazy when it started out as notes, is we're going to actually put 90 sessions together. So there's a call for papers out there at the moment as well, that if you've got a story to tell about your DevOps learning journey, then would love to hear it, as well as talk about any tooling that you're using or passionate about as well. That'd be awesome.
Very good. Just wanted to remind people that There are endless opportunities to get involved, and really want to thank Michael for all the work that's being done on this, because it's a lot of hours. And so just want to give him a shout out for that. Thank you, Michael. Round of applause, please.
Thank you.